So let's go on to the other side of the coin, if you will, and talk about the other really important idea when breaking up things into modules. And that's this idea of cohesion. So in the last lectures, we've been talking about that idea of coupling, where we don't want the modules to be too tightly associated with one another. But with cohesion, what we want is we want each module to be as defined as possible, meaning it only carries out a single task. So we don't want to have a whole bunch of modules doing a whole bunch of things, meaning we don't want either really large modules or this module does a little bit in this category, this module does a little bit in that category, and down here and in this category. And then, of course, the other example is just a really large one where you just have a single file doing everything. We want them to be very focused so we can take things out and we can sort of almost mix and match them. We have that idea of modularity where we could take a module and replace it with another module and it would work perfectly. So for example, if this was the color red module and this was the color maybe green module, we could take the red module out and stick the green right in its place and it would work perfectly fine because of how defined and how specific these two are. And so that's what we're looking for with cohesion. Now, these two, like I said, they work against each other. You can have a really, really strong, cohesive set of modules that are very, very tightly coupled. And you can have a very, very loosely coupled set of modules that is very, very weak in cohesion. The example that I like to use for this is if we have one giant file. If we have a single giant file doing everything, well, by definition, we actually have very loose coupling. There's no linkage to any other files here. This module is loosely coupled. It doesn't have any linkings. We could actually say this is no coupling in this situation. So that would be fine in coupling, but with this, we have the weakest of all cohesions. So what we have here is a file that does everything and therefore has no purpose. It has no defining factor of what it's supposed to do. And so because of that, instead of just looking for one or the other, we have to try to get the two to meet. We have to find a balance. And that is where we go with this principle of strong cohesion and loose coupling. We're not going to be able to get perfect on each side, but what we're looking for, if they were both like graphs, like this right here, we're looking to try to maximize it right in the center here. We're looking to try to optimize our program so that it is pretty nicely and loosely coupled and at the same time pretty strongly cohesive. If we can do that, we have a great program, we have a great design, and it'll make the process of maintenance and building it so much easier. So in the next lectures, let's start getting into some of the different levels of cohesion like we did with coupling and see some of the common pitfalls and stuff that come with building with respect to coupling.